In this video, we're going to talk about vertical shifts. For sine and cosine functions, as well as all other functions, a vertical shift is one where the interior of the function isn't being added or subtracted, but the exterior of the function is being added or subtracted. Now, in this situation, you might think that that minus 1 is sitting inside that cosine function, but it's important to remember that if there's no parentheses in here, it is going to be the cosine of just x, and then once we have a new addition or subtraction sign, the function stops. So this is supposed to be the same as 1/2 cosine of x minus 1. Okay, the only time that this is equal to x in parentheses minus 1, end your parenthesis, is when the actual parentheses are shown there. So how do we do a vertical shift on a sine or a cosine function? Well, it's no different than any other function. We're going to go ahead and stick to the amplitude being 1/2, my period in this case being 2 pi because there's nothing multiplied by x. My phase shift there isn't 1, specifically because there's no addition or subtraction on the inside, and all I need to make note is that there's a vertical shift down by 1 unit. So when I go to graph this function, all I need to start with, and again, I'm going to start with the real basic function, having 2 pi, cut that in half pi, cut that in half pi over 2, multiply that by 3 pi over 2, and then 0. My high point is 1/2, my low point is negative 1/2, and cosine is supposed to start high, 0, low, 0, high. And just like I started with the phase shifts, I'm going to shift each individual point left and right. For this one, I'm going to shift every single one of those points down 1 unit. So my end result graph, again, notice how I didn't fill this in because it's not necessary. I just needed those 5 points to know what the graph is supposed to end up being like. I'm going to take 1/2 and I'm going to subtract 1 value from it. That's going to bring it down to that negative 1/2 point. So in this graph, maybe I should give myself a little extra distance here. If this is my negative 1/2, I'm going to plot that 1/2 up here just in case, and I'm going to go ahead and say that I have this is negative 1, and this is negative 3/2. Now, in some cases, what you might do is you might go ahead and put yourself a nice dotted line at negative 1. The reason why you might do this is because that is your new so-called x-axis. It's the location where the graph is going to have its centered point. Again, here is where that center line occurs. Now it's shifted to this location because the whole function has been shifted down 1 unit. So what you could do here is you could say, well, wait a second, the distance from this axis has to be a value of 1/2. So I'm going to go up to 1/2, and then I'm supposed to go back down to 0, then the low point, 1/2 below that location, then back up to 0, and then back to my high point, such that my 0 line is no longer 0, it's my negative 1 line because that's the shift. So on the x-axis up here, I'm still going to go ahead and put my period of 2 pi. I'm going to cut that in half, pi, I'm going to cut that in half, pi over 2, I'm going to multiply that by 3 pi over 2. Don't forget 0. And then I'm going to go ahead and, again, either shift each one of these 5 points down or use this dotted line as your new 0 location. So if I subtract 1 from here, it goes here. If I subtract 1 from 0, it goes to negative 1. Then my low point, back to 0, back to my high point. My high point, again, being this negative 1 location. If it helps, you might also do H, 0, and L to label where your high, low, and 0 locations are. And then again, when you're sketching these functions, just do a nice, smooth graph to the best of your ability. It has to have curvature to it. Again, if it looks like this, it's not a cosine curve. That looks more like an absolute value or a quadratic, and that's not what we're looking at. This, again, is supposed to curve down and back down as it gets around those sections. But that's how you graph any kind of vertical shift up or down of any sine or cosine function. It's you graph those original points and then shift them appropriately, very much like that of the phase shifts of these sines and cosine curves.